Hello again, my wonderful Algebra 2 trig people. We're going to talk about Unit 2 in this video, and it's going to cover quite a bit of stuff, so we're not going to hit every detail of every example, but I will get you through it. So when you're working with i's, remember, when you're adding and subtracting, we just treat them like combining like terms. So 2 minus 3 is going to give us a -1, -3 minus 2 for our i's is going to give us a -5i, and we're already done. Nothing else to do. But when we multiply, we have to distribute both the 4 and the 3i. So we're going to get 4 times 2 is 8, and 4 times a -5i is a -20i. 3i times 2 would be plus 6i, and 3i times a -5i would be a -15i squared. But that's where the trick comes in. You have to remember that I squared is equal to a -1 because it's an imaginary number. And, we get I from taking the square root of 1. So now this actually becomes 8 minus 26i, and a -15 times a -1 is going to give us a positive 15. Combine like terms one last time, and we have 23 minus 14i, because that's supposed to be a minus 14, not a minus 26. Don't know where I was on that one. When we're dividing, you're not allowed to have an I in the denominator, so we're just going to multiply the top and bottom by what's known as a conjugate. It means we keep it the exact same, but we change that middle sign. And when you multiply, it will get rid of that letter. But now we're just going to multiply the top like we did in the last example. And we're going to end up with 8 plus 14i plus 3i squared all over 16. And then this is the fun part. We would have a plus 4i minus 4i, which will cancel. That's why we multiply by the conjugate, minus I squared. After you simplify everything on the top, you get a 5 plus 14i, because remember, I squared is a -1, so a -3 and 8 gives you 5. All over, again, our 4i's and -4i's, they cancel. And a -I squared is a plus 1, so that's going to give us 17 in the denominator. Okay? So that takes care of simplifying with i's. This one we're going to solve by factoring. Now, we already factored a little bit in Unit 1. So to factor, obviously the first thing you always want to do is factor out a GCF as possible. We can factor out a 2x out of this, leaving us with x squared minus 8x plus 15 on the inside. And next we're going to just factor the way we've always factored, what multiplies to 15 but adds to a -8. That would be an x minus 5 and an x minus 3. Now once everything is completely factored, you set each thing equal to 0. And you end up with x equals 0, positive 5, and a positive 3. Okay? Now the next example, we would start by factoring out a 2x cubed, leaving us with a 4x squared minus 1. That's equal to 0. But this is the difference of two squares, so we can take that a step further. 2x plus 1 and 2x minus 1. Of course, our 2x cubed out front. Now that we are completely factored again, set everything equal to 0. So if we set that equal to 0, we get 0. And subtract 1 divided by 2, we get a -1/2. Add 1 divided by 2, we get a positive 1/2. And we're done. Now the last one has a little trick that you have to remember. 2x squared plus 7x plus 5 is equal to 0. So you can't factor and solve until you're equal to 0 first. Then you can factor. Now we would factor this using splitting the middle term or Batman, either way you like. We already talked about that in Unit 1, so we're going to just skip to the factoring part. 2x plus 5 and x plus 1 will equal 0. Again, set each term equal to 0. Subtract 5 and divide by 2, you would get x is equal to a -5/2 for that one. and subtract 1, and we get a -1 for that one. And we are done. Now, if you are told on your final to solve by a certain method, you must do it. So another method is solving by square roots. You can have a whole bunch of different kinds of radical answers. You use this form, or this is one of the many forms you can use to solve a quadratic when it can't be factored, okay? Now we're going to first subtract 9 to both sides. We'd have 4x squared is equal to 6. Now we have to divide both sides by 4, and we get x squared is equal to 6/4. And you could reduce it, but I would advise you not to, because now we're going to take the square root of both sides, and that'll give us a nice denominator, because remember, you can't have radicals in the denominator. So x is equal to, do not forget your plus or minus when you are solving by square roots. So we have the square root of 6 over 2, because the square root of 4 is 2. And you're done. When they look like this, the first thing you have to do is get rid of anything around the parentheses. There isn't any, so then you can jump to square rooting both sides. Do not forget, the square root of a negative turns into an I, so we're going to have an x minus 3 equals plus or minus 2i root 2. So remember, you have to simplify the square root of 8, just like we always have, but that negative makes it imaginary. Add 3 to both sides, and we end up with x is equal to 3 plus or minus 2i root 2, and now you're done. Now this last example is what I was talking about for number 8. You have to get rid of stuff around the parentheses first. So the first thing you would do is add 3 to both sides, so that would give you 2 times x plus 4 quantity squared equals 24. Now you would divide both sides by 2, giving you x plus 4 squared is equal to 12. Once the parentheses are by themselves, you need to get rid of the squared symbol by squaring or square rooting both sides, leaving you with x plus 4 is equal to plus or minus 2 root 3. You must simplify the square root of 12. And then subtract your 4, and x is equal to a -4 plus or minus 2 root 3, and you are good to go. Another way to solve quadratics is by completing the square. Now this is the one that's a little bit different. With factoring, you want it equal to 0. By completing the square, you only want your x's on one side, so we're going to move the 8 to the other side, giving us 10. Now, if you forgot what this was, this is where we would leave a little bit of space after each one of those, because what we're going to do here is say half of 6 is 3 squared is 9. And we're going to add that to both sides, just like we did in the last video with writing in vertex form. However, this part's going to be the same as well. X plus 3 squared is equal to 19. But instead of moving things back to the other side and putting a y equals in front of it and calling it done, now we're solving. So this is just like the previous 3 examples, where once we get the squared term by itself, we square root both sides to make it go away, leaving us with x plus 3 is equal to plus or minus the square root of 19. 19 cannot be simplified, so we leave it alone, subtract our 3 from both sides, and x is equal to a -3, plus or minus the square root of 19. And now you can consider yourself done. Okay, this example over here, first thing, obviously get that 3 to the other side, so that would give us 4x squared minus 8x. And that's equal to a -3. Leave a little bit of space. Just like the last video, you cannot complete the square with a number in front, so we have to factor that out, whatever it is. So that's going to give us an x squared minus 2x, and now we can take half of 2 and square it, which is going to give us 1 over there. That's equal to a -3, and remember, you must multiply the 4 to this term before you add it to the other side over there. All right, that's going to leave us with 4 times x, half of a -2 is a -1 squared. is equal to 1. You must divide both sides by 4 first, because you have to have the entire squared term by itself before you square root both sides now. And remember the plus or minus, so we're having x minus 1 is equal to plus or minus, now the square root of 1/4 over here is going to give us 1/2. Okay, now we're just going to add 1, and we're just going to have x is equal to 1 plus or minus 1/2. Now you can take that a step further, obviously, because this is not an imaginary number. There's no radical, so we can combine those. So 1 plus 1/2 would be equal to 3/2, and 1 minus 1/2 would give us 1/2. Now you're done. Okay, now the last example, again, we already talked about this in the last video. We have to factor out the 1/2, but remember, when you're factoring, it's dividing. So 4 divided by 1/2 is 8. Okay, and then half of 8 is 4 squared is 16. That's equal to 9 plus half of 16 is 8 before we put that on the other side. So that's half of x, half of 8 is 4, squared is equal to 17. You must multiply both sides by 2 to get rid of the 1/2. So that's x plus 4 squared is equal to 34. Now you get to square root both sides. The square root of 34 cannot be simplified, so that's going to leave us with x plus 4 is equal to plus or minus the square root of 34. Subtract 4 from both sides, and x is equal to a negative 4 plus or minus the square root of 34, and you are done. Okay, so that's completing the square. That one is a little challenging at times, but not always. Finally, the last set of problems covered multiple topics in one. So remember, you have the big old square root of b squared minus 4ac as part of your quadratic formula. But the first thing we're going to do is find the discriminant, because the discriminant is just what's inside that radical. So remember, the discriminant all by itself is b squared minus 4ac. And remember the number and type of solutions. If your discriminant is positive, you have 2 real. If it's 0, you have 1 real. And if it's negative, you have 2 imaginary. So that's what we're going to do here. So you must be equal to 0 again, but then it's b squared. So a negative 4 squared minus 4 times your a value of 5 times your c value of a negative 1. And if we do that, we're going to get 36, because we have 16 times, or 16, and then we have a negative 4 times 5 is a negative 20 times a negative 1 is a positive 20. So 16 plus 20 is 36. So that right there tells us that we are going to have a positive discriminant, so we have 2 real answers coming our way. So now we're going to do the quadratic formula part. So remember, the quadratic formula is opposite of b, so that's a positive 4, plus or minus the square root of b squared minus 4ac, which we just did. It's the discriminant, 36, all over 2 times our a value of 5. And now we're just going to simplify. So that's 4 plus or minus 6 all over 10. 4 plus 6 is 10 over 10, so we have x is equal to 1. And 4 minus 6 is a negative 2 over 10 is a negative 1/5. And we're done. Okay, and the next couple of questions are going to go the exact same way, but remember, you must be equal to 0 first. Okay, and then of course our discriminant, we're going to have a 4 squared minus 4 times 1 times 4. And that's going to give us 16 minus 16 is 0. And remember, that means we have 1 real solution. Move on to the quadratic formula. Opposite of b would give us our b value is a negative 4. Plus or minus the square root of 0, which obviously, no, it does not exist. All over 2 times 1 is 2. So negative 4 divided by 2 is just x is equal to a negative 2. Because the square root of 0 is 0, and there's no such thing as plus or minus 0. So we're done. Last question for this unit. Quadratic formula. First, we're going to find the discriminant of b squared, which is 5 squared, minus 4 times 4 times 9. That's going to give us a negative 119, which tells us this is going to have two imaginary solutions. So now we go do the rest of it. Opposite of b is a negative 5, plus or minus the square root of negative 119. All over 2 times 4 is 8. And the square root of 119 can actually not be simplified. So our answer is x is equal to a negative 5 over 8 plus or minus I root 119 all over 8. Now I split that apart because remember I've mentioned before, sometimes these can be simplified or reduced and you want to do that. So if you would have left it as negative 5 plus or minus I root 119 all over 8, you would be correct. But if you split it, you will see when things can be reduced a little bit easier. All right, that's it for Unit 2. This is Longo and I'm out. See you, bye.